Hello, and welcome back to another episode of the Future of CRE Sustainability. I'm your host, Sean Swentek. Today, I'm speaking with Dan Golding, Chief Technology Officer at Appleby Strategy Group. Dan, thanks so much for joining me today.
Thank you for having me.
Excited to have you on the show. Love talking with a data center expert. Now, you famously coined the term fake data center. What exactly is a fake data center, and why should the market be wary of it?
So we're in sort of a unique time period in terms of data center development. For the last 2 decades, the data center industry has been developing data centers in increasingly large amounts. About 18 months ago, 2 years ago, AI really took off. And when it took off, a lot of capital and a lot of demand sort of rushed into the sector. And as what you might see in any data center sector, there was, a form of speculation. And the form of speculation we've seen is a lot of folks coming in claiming they have significant data center developments, when in reality, they don't. They don't have land under control. They don't have power. They don't have network. Data centers are a complex beast to build. We have a lot of folks who aren't experts, who have no familiarity at all, who've rushed into the sector and claim that they're developing projects, even putting out press releases, attempting to get a lot of attention, when there really is no there. And it's something we haven't really seen. You don't see, 100 press releases claiming that there's new apartment buildings going in that are essentially fake. But when you talk to the folks who are the buyers, they're inundated with proposals and solicitations that are clearly not real from teams of people who, when you look at the team, no one has actually ever even been inside a data center. Mm-hmm. It's that extreme because there's this perception that there's a lot of money at play. And while there is a lot of money at play, unfortunately, the fakery is gumming up the works. And I wrote a series of research notes called The Age of Fake Data Centers that sort of talk about, over the course of 4 months, sort of the adventures of the data center industry as it's trying to deal with this totally unexpected phenomenon. And now you see at some of the data center conferences, there are no more fake data center t-shirts that we've distributed. The ironic thing is, occasionally you see someone touting a fake data center wearing one. One of the most ironic things that's happened is I had breakfast with an individual who said, "Hey, I really need you to start writing about fake data centers because all the investors I'm trying to pitch keep saying that my company is a fake data center." And I said, if they keep saying that, it's probably not a me issue. It's probably a you issue.
If you had to take a stab at sort of thinking about what percent of data centers that are in the queue or being proposed actually do get built, how many of them are fake? What percent is actually real in there?
About 90% are fake.
Wow.
Yeah, which is extraordinary. It's cooled off a little bit in the last few months. I'd say, February was probably the peak of fake data centers. And now when people have discovered that they can't just, wave, a proposed site in the middle of rural Canada at a hyperscaler and get a check for $1 billion, now that they've discovered that that's the case, it's starting to cool off, and more of the projects we're seeing tend to be real, which is good because it was hard to execute on the real projects because, the buyer's time was all taken up trying to discern.
You've been in this game for a while. You've overseen a lot of tech advancements, efficiency gains. How does your donut model of interconnection change the infrastructure requirements for data center properties?
So that's a great question. That goes back in history a little bit. Back in prehistory, if you wanted to connect to the internet, there was this sort of very quaint hierarchical system of tier 1, tier 2, tier 3 internet service providers and carriers. One of the things that happened about 15 years ago was that model was broken entirely. And I'm one of the people who broke it, I'm happy to say, by breaking that hierarchy. The hierarchy, it seemed like a good idea back in the early days of the internet, but it didn't scale well to what we now call the hyperscalers. It didn't scale well to broadband. And so breaking that model was really, really important to advancing the state of the art and where we are now. And now you see something totally different. You see data centers connected with really, really large amounts of dark fiber. You see, which is sort of extraordinary. It's not anything we've seen in the past. You see the internet not composed of the data centers, but composed of the folks who own the data center, so to say, which is to say, a lot of folks at home probably think, oh, if someone builds, a large data center campus, they're ordering internet service from someone. But in reality, that's not what's going on. What's going on is those data centers are, in fact, where the internet lives. And you're not ordering internet service. What you're ordering is sort of dark fiber backhaul that you like that goes back to the internet exchange points where you interconnect freely with, a Google, interconnects with a Meta, interconnects with a Comcast, interconnects with AT&T, interconnects with a Zayo, interconnects with a Lumen, without worrying about, hey, I have to call the phone company and order some internet service. That's something we do at home, but it isn't something we have to do in the data center. And that's enabled us to scale from, pretty much the biggest internet circuit you can order today is about 400 gigabits per second, which is awfully large. But the average data center on the day that it opens, typically utilizes about 200 terabits per second. So that's something, 3-4 orders of magnitude higher. So, all of the things we do today are sort of predicated by having an arbitrarily large amount of bandwidth between these data centers. And I think especially as we move from internet applications to cloud and now to AI, having that sort of ubiquitous bandwidth, that huge amount of dark fiber is really, really important to, keeping things moving. Because one of the kickers here is a lot of the folks listening to this probably think, okay, what you need for data centers is landed power. And that's true. But without the third piece, which is the fiber, which is the network, you've got a really cool building, but you can't put anything in it. That network is all important. That's something that folks developing data centers have had to learn the hard way, that you can have the best building with the most power. But unless you've got that interconnection, that network interconnection, it's not a commercially viable project, which has been, phenomenally hard for a lot of people who've come from the real estate development side.
You mentioned one of the legs of that chair is power. What's driving the dramatic increase in power density at data centers? And how can we balance this against nationwide sustainability goals?
This is tough. And the thing that's driving this is AI. One of the things we found is that AI is great. AI is going to drive a lot of changes in our society. The way I think of AI is that what if everyone had a administrative assistant? Someone who took care of all the little things in life, travel, doing expense report, setting up meetings with people. What if you didn't have to do any of that stuff and you got 2 hours, 3 hours, 4 hours a week back? That would be really nice. And I think, that's the least of what AI can sort of unlock for us. I don't think ChatGPT is it, but the cost of this is that you need to be able to do certain kinds of math operations to create these AI models and to evaluate queries against those models. One of the things that we found is that the kind of CPUs that we use in a laptop aren't great at these operations. They're okay. But what's really great are the kind of chips that are in our video game machines. So if you go to your Xbox, your PlayStation, and you crack it open, or even a gaming laptop, there's a kind of chip in there called a GPU, graphical processor unit. A graphical processor unit is called that because it's very good at a kind of math called linear algebra or matrix math. And that's the kind of math that's used to do a lot of computer graphics. It's also used to do AI calculations. It's the same calculation for rendering, FIFA soccer as it is for doing ChatGPT. So the kicker is those chips take a lot of power. And those chips run really hot. And so the way to think of this is a rack of servers in a data center might take 10 kilowatts. And that's a regular CPU to do cloud. And so that's the equivalent of maybe 3 regular normal houses in a single rack, 19-inch wide. A rack of GPUs used to do AI, on the other hand, might be 120 kilowatts. So 12 times that in a single rack. So hot that you can't use air to cool it anymore. You have to use some kind of a liquid, like PG-25, Dow Frost. There's all kinds of different coolants you can use. So that's the equivalent of 30 houses. It's an entire neighborhood in a single rack of power. So it takes a tremendous amount of power to do this. So on one hand, we want to transform society in ways both large and small. On the other, it's going to use a lot of power to do it. In order to make that work, that puts a lot of strain on the electrical power grid. It puts a lot of strain on generation. I think a couple of things are going to happen. Three things. One is, I think the data center operators are going to have to say, these costs can't be passed on to consumers.
Mm-hmm.
And I think that is actually the goal of the data center operators and the hyperscalers, that, the utilities aren't really there. The utilities are not operating exactly the way the data center folks want them to. The data center folks don't want, the average consumer doesn't pay 1 penny more. Utilities are really struggling to figure out how to make any of this work. So one thing is, this can't be passed on to consumers. The second is, we're going to need a lot of natural gas power plants, relatively clean natural gas power plants built adjacent to or on data center campuses, so that these data center campuses aren't destabilizing to the electrical power grid. In fact, the opposite. If I'm building a 500 megawatt data center campus and a 700 megawatt natural gas peaking plant right next to it, it can be stabilized to the grid. And I think the third issue is we need to really put a lot of money into developing these small modular nuclear reactors. They're absolutely essential. They're really important. It's going to take 6, 7, 8 years to get these out there. But in terms of changing the world for the better, these SMRs are a zero carbon source of power. They're very safe. If built in large enough numbers, they can be quite economical. And I think the only folks who have the money to make this a reality are the large cloud companies who are getting ready to make big investments. The question is, who can afford, the first 50 SMRs? Well, Google, Meta, Microsoft, Amazon, Apple, Oracle, the list goes on. They can afford these and they will.
Mm-hmm.
I think that's going to, create a new green renaissance in this country.
You've overseen 25 billion in hyperscale build out. What's the critical flaw you see in traditional building structures trying to accommodate AI workloads? And it's dawning on me that I think that's the first time we've said hyperscale today. So maybe a quick definition of that for the listeners.
Yeah. So hyperscale traditionally meant sort of the 4 really, really large data center user developers, the Microsoft, Amazon, Meta, Google, it's expanded though. So that list now includes, folks like Alibaba, ByteDance, Oracle. There's really even more folks out there. There's what they call the neo clouds, like Applied Digital, like CoreWeave. So that list is actually getting considerably longer as time goes by. Certainly folks, think of OpenAI, Anthropic. So, it's a term. There's hyperscalers, there's superscalers, there's some folks sort of amusingly see baby scalers for folks who are just getting in there. But these are the folks who are building and operating the really large at scale data centers. But to answer your sort of question about, what is sort of broken about, conventional data centers, it's fine. For 25 years, it was easy to build and develop data centers. We had about the same design with a few efficiencies, and you put money in and you turn the crank and you had your supply chain and you built the same thing year after year in pretty much the same locations. AI has broken all of that because, the power densities are totally different. Now we have to use various kinds of liquids to cool things. The physics and the engineering are very different. The locations are different. The applications are different. And so for the first time, it's like a lot of the companies that were building data centers didn't have a strategy function. They didn't have to think about what choices they made. They just made the same choice repeatedly that worked out for them because people kept using more, Instagram or whatever. That's not working anymore. And so now there's a need for this sort of strategy function, this, you didn't, for many years, there wasn't a chief technology officer at any of these companies because you didn't need one, because you just needed to execute repeatedly. Well, that in the last 18 months, that has gone right out the window. Mm-hmm. So now you're seeing this function come back where people are trying to figure out, what is the strategy? How do we go forward? What is the technology? Because the customers, those hyperscalers don't agree on what it is. They don't know. They're looking to all kinds of people. And, so they might look towards an NVIDIA or an AMD or, a Meta or Digital Realty Trust or Equinix. And a lot of those folks are looking to each other to try to come to a consensus or agreement on what the new designs and the new decisions and choices are going to be. We don't know what a data center is going to look like in 5 years, which is particularly tricky because these are 30 or 40-year assets that cost billions of dollars.
Mhm.
We're having to, do designs now that are predicated on being able to change things mid-construction or a few years post-construction. We're having to build an optionality that we never had to build in before. Think of it this way. So let's say you're going to build a 500-unit apartment building. But let's say, and you expect that to last for 30, 40 years, right?
Mhm.
Let's say that halfway through construction, you may get told to change the number of bathrooms in every unit. Halfway through construction, you may be told to increase the size of every apartment by 50%, or add 3 levels of parking garages. Like most people would think, well, that's impossible. You can't do that. That makes no sense. That's unsustainable. Well, that is the data center industry today. And things have gotten very, very difficult very, very quickly. The good news is there's a lot of people who really know what they're doing in this sector. And, but even those folks who are really experienced are under a great deal of strain. And, one of the things I love about this sector that maybe is unique amongst, pieces of the real estate world is that there's a lot of folks coming together from the different companies, from competitors, to try to figure this out together. It's a rising tide sort of lifts all boats. We're facing this sort of massive technology challenge. And so, a lot of people will just call each other and say, hey, how are you guys solving X? Because we've got a $1 billion project that's been paused for 9 months and we're trying to get it running again. And it's nice to see. It's what we might have seen in the early days of the internet, where people collaborated to try to solve really intractable technical problems. We're seeing this again with data centers today, to try to make AI work.
The third leg of the stool that you mentioned earlier was land. I know, orchestrated a land deal one time that went from a value of 20 million to 500 million. What are the factors in play that create that kind of value explosion? What should people be looking for as they're analyzing land for a data center?
So location. Like location matters for everything in real estate, and it matters a lot for data centers. One of the things that matters a lot is proximity to internet exchange points, which are the places where traffic is exchanged between internet networks, and proximity to other data centers. And, land values start to go way, way up when you're near other data centers. And it's sort of counterintuitive. So you'd think, hey, Joe built a shopping mall, or Joe built, an apartment building in location X. Therefore, I'm going to build one right next to it. Well, that doesn't make any sense. That blows up the head of a lot of folks who are used to sort of conventional real estate development. But in data centers, that's exactly what we do, because there's something called a network effect. So a guy named Jay Adelson, who founded Equinix, which is sort of the grandfather of data center companies, sort of coined this term, the network effect, to say the data centers become more valuable when they're near other data centers and when they're near interconnection. And it's not linear. It's really sort of exponential. So that first data center you're going to build, maybe the land around it isn't that valuable. But by the time you're on the 10th data center and the value, the network effect is going to the ceiling, that land is worth more and more and more. And, that land deal you mentioned was in the middle of Ashburn, Virginia, which is the data center capital of the world. And there was a time when you could get land here for, $25,000 an acre. And, 10, 15 years ago, $200,000 an acre. Right now, that land goes for $5.5 million an acre.
Wow.
Which is just extraordinary. And it's the network effect. It is the fact that, this isn't just a piece of land. It's a piece of land with a very expensive asset on it that is connected through a super dense fiber network with other very similar data centers. So it's that communications network is sort of all important. And it's hard to make a connection between that and anything else in the world of real estate, because that those dense fiber networks don't matter to anything but the world of data.
How is GPU deployment changing the fundamental economics of commercial real estate?
So I think the fundamentals of commercial real estate are that, you build and maybe you overbuild and you get oversupply and you get undersupply, and so everything, there's these sort of oscillation that happens over the long term. GPUs are different though. To build a data center that supports GPUs and the GPUs themselves, there's so much money involved that, a standard 80 megawatt data center these days, before you put in the first GPU, it costs you $1 billion for one building. And then on top of that, by the time you put the GPUs in, you're maybe at $5 billion for a single building on one campus.
Wow.
And so you can't build speculatively. It's impossible. You can't get finance to build speculatively. You are effectively, it would be the equivalent of I'm building a Class A office building, but it has to be 100% leased, before the first ship hits the ground. Or I'm building an apartment building, but 100% of the apartments have to be sold. And it's just really, really unusual. And that lack of being able to go spec means that the whole system lacks elasticity. So if you've got unexpected demands, good luck trying to fill them. What you get is there's a few data centers where the original customer is going to pull out. They're going to break their contract and pull out. And, even those, I've never seen one get all the way to completion before someone else has rushed in. And granted, the only elasticity in the system are these cancellations. We saw one in Ellendale, North Dakota, which was an AI training data center owned by Applied Digital. CoreWeave just rushed in after before completion. Although it was getting within about 6 months. We've seen that with some data centers that Microsoft has sort of canceled on. Other people like Google have sort of rushed in, but we haven't seen any building even get to completion. It's funny, in the residential market, you see sort of these fast delivery houses where the original owner has sort of failed to execute against their contract. And for folks like Toll Brothers, they make a lot of money on this. None of this exists in the data center. It is impossible. It simply costs too much. And, there's no speculation. There's no elasticity. It's as if I'm going to order a hamburger, but I need to order the cows and the grass and I need to plant the wheat for the bun. And that is the world data centers live in. And it is particularly challenging because, if you want to order something, you're ordering it 3 or 4 or 5 years in the future.
How are data center operators rethinking their real estate strategy as AI workloads become more dominant?
So that's a great question. For one thing, for a long time, they were not land banking. They were building stuff as it came, and they thought the hyperscalers and the data center operators, they thought they were the kings of the world. They thought they knew exactly what was going to happen. We were complacent. We thought, okay, cloud and internet applications are going to grow about 20% year over year. We knew exactly what's going to happen. We don't need to land bank. We don't need to have any excess capacity. Everything's going to be fine. Well, then AI comes out of nowhere, which we should have known. But, unfortunately, sometimes when the technologists are weak and the CFOs are strong, you lose your ability to rapidly innovate. And things have been so static for so long, the CFOs have effectively ruled the roost. Well, what we found as an industry is that we weren't able to respond quickly because, we lacked these land and power banks. And so you had all these developers, all these buyers, and all these hyperscalers rushing in to try to find land, to try to find power, and try to find fiber, all fighting against each other. What's happening now is they're starting to rebuild those land banks and those power banks so that, in a year or 2 or 5, they've got the capacity to grow without having to sort of run around and try to sort of rapidly come up with a strategy. This is something that people never should have rejected in the first place. It was a false economy imposed by the financial folks, which ended up costing a great deal more money. One of the hyperscalers, 2 quarters in a row on their earnings call, said they fell short on cloud earnings because they didn't have enough data center to fill orders, which is the last thing. You never want to stock out. And, what we saw is a world of false economies driven by finance professionals overruling the technologists, making it impossible for us to innovate. And now things are swung the other way.
You've been a participant in this market as it's 5x over the last few years, specifically in like hyperscale. Even with the fake data center problem, what do you think the future growth path looks like over the next 3-5 years?
I think it's going to be enormous for a while. I think for the next 3, 4, 5 years, when we say 2029, it's going to be really significant. I think there are limitations. There's going to be power grid limitations. There's going to be economic and financial limitations. I don't think things can grow at this pace indefinitely. I don't think there are simply limitations in terms of physics to prevent us from doing that. I also think that at some point, the AI field is going to have to get more efficient. So we're using all these GPUs. I think one of the things we've seen in history is, folks use large amounts of computing that's unoptimized, and then eventually people figure out how to optimize. So, with your favorite streaming video service, over time, folks have figured out how to optimize your reduce the amount of bandwidth that your cat videos used. And it can be a lot, the optimization can be significant step functions sometimes. I think over, between now and 2030, we're going to see a lot more data centers come online. We're also going to see a lot more optimization activity because we can't grow the way we're growing indefinitely. We will use up all the electricity on the planet, all the water on the planet. There'll be data centers everywhere. This is not going to fly. So I think we're going to see some strong optimization. I think there's a lot of money optimization. This stuff costs so much that if you can shave off 10% or 20%, out of money you can make is really, really significant. So I think, and I think at the same time, people are probably going to panic about it. Oh my God, the sky is falling. NVIDIA is not going to grow like 80% this year. Well, no company can grow 80% every year. And I think we should just be aware of past the real estate and technology patterns of growth. Nothing is a hockey stick forever. Things grow and they're going to grow for a couple of years. And I think we are going to see, that curve starting to trail off because it's got to.
Back on the subject of location, what's the most overlooked aspect of site selection when evaluating a property for AI and cloud infrastructure?
Without a doubt, no. I've seen very, very smart folks who come to me and said, we've got this great property, which has this power, but we keep failing due diligence with our customers, so we can't figure out why. I said, okay, can you show me the network? Can you show me the optical fiber? And they say, well, it's somewhere on the property, but we don't know what the deal is. So, well, that's why you keep failing, because you don't know even the right question to ask to determine if this property can ever have an AI data center on it. So, along the same lines, there aren't a lot of people you can talk to. I get asked all the time for, hey, will you consult with me? And I said, no, I'm not a consultant. I don't really do that. I can't really help you figure out if your property has the right network on it or can be built to it. They said, well, do you know anybody? And, well, not too many people, actually. So this is a tough one. I can find a utility consultant. I can find a civil engineer. Finding people who can help you get an AI quality network extended to be able to build an AI data center, that's really hard. And that's the thing that's the number one cause for a property to fail due diligence. That and it just not having any reality at all. Folks who don't control their property, that kind of stuff.
So talking about the big dollars coming into this, I know you advise private equity and infrastructure investors. What's the one metric that really determines success or failure when it comes to investing in data center real estate?
I don't even know that it's a numeric metric. It's experience. The folks who succeed in this space are the folks who have experience doing it. No matter how good your property is, your power, or anything else, if you have never done this before, your execution risk is extremely high. And so, we see lots of inexperienced teams rushing into this segment. And you can tell without even looking at their project that they're probably not going to be successful because they don't understand there is a value chain in the creation of these AI data centers where you've got to get it 100% right. 98% is an F, which is just astounding if you think about it. But, the chance that an inexperienced team is going to actually bat 1,000, it's impossible. You have to have made the mistakes with other people before. You have to have worked as a team with people who know what they're doing. And so the difference between an experienced team and an inexperienced team is like night and day. And the true drawback we see in this sector is the number of folks who are dangerously overconfident in their ability to execute. I once talked to a gentleman who said, I built 300 hotels. How different can data centers be? And this was a very smart guy. So he realized very quickly there was a huge difference. This was a brilliant guy. It took him about 45 minutes to figure it out. But there's a lot of folks who aren't quite as smart as that and who are sort of dangerously overconfident with other people's money. And that is the thing I guess I'd leave you with, is that there's a lot of danger. And the easiest way to tell is to look at the team.
For my listeners who might be sitting on some vacant properties and are trying to cash in on this craze, is there a process that they can go about to evaluate whether their property can support AI infrastructure?
The advice I give them is not to try.
Yeah.
And that is sort of like, maybe counterintuitive, but it's not a craze. The person who says, hey, I've got some land, I'll see, it's not going to work, right? Like you've got a 1 in 10,000 chance that it's going to work. Now, if you've got some strong reason to think, let's say you've got land that's adjacent to a bunch of other data centers, well, then you should definitely check it out. And, there's folks you can hire to check it out for you who have about a 70-80% accuracy rate. It's a little tricky. But for the average person, like a lot of people are going to listen to this and think, hey, there's a gold rush. They're not going to listen to the negatives. They're going to say, oh, hey, there's money. I guess the thing I'd encourage is there's a lot of people working for well-established data center real estate developers and hyperscalers who are looking for land. If somebody gives you a call, you should talk to them. But if someone doesn't give you a call, you should probably take that as a sign that maybe this is not something that is easily accessible for your property.
5 years from now, what's going to separate the winners from the losers in the AI race?
So I've got to say experience, access to capital, and, access to the end customers, I think is going to be very, very important. But, getting back to what we talked about before, it's with all real estate, location is what matters. If you've got a bunch of land in Ashburn, Virginia, or New Albany, Ohio, and you've got power there, and you've got a network, Reno, Nevada, there's just a couple of places that are, because of the way the fiber lies, are really attractive. If you've got those things, you've got an excellent chance of winning. If you don't, your chance of succeeding isn't super strong. But, it's funny, is with all real estate, it comes down to location.
All right, I'm going to move to some lightning questions, quick hits, your quick answer on these. When it comes to renewable energy sources for data centers, in the next 5 years, solar, wind, battery, nuclear, assuming we don't call nat gas renewable, what's going to be the fastest growing energy source that's renewable for data centers?
None of the above.
Interesting and fair. What is one property technology solution, proptech, that's driving unexpected success in the sector or that uniquely solved an issue that needed solving?
Ironically, AI for construction management, which there's no actual connection. It just happens that it works really well.
So this goes back to question one, but can data centers grow as expected while keeping an eye on sustainability?
With great difficulty.
So this is the last one around that. Complete this sentence. The biggest myth about sustainable data centers is
that solar and wind are the solution. They're a part of the solution, but you can't power an AI data center, sadly, with wind and solar today.
And last one, if you had the funds to invest in any sustainable technology right now, what would it be?
Small modular reactors.
I had a feeling you might say that. Based on what I saw in the news recently, you're not the only one. Dan, this was really a pleasure. If someone wants to learn more about you and your work, where's the best place for them to go?
They should go on LinkedIn, and I write research notes periodically, freely available for anyone who wants to take a look.
At Dan Golding on LinkedIn. Make sure you look him up. To all my listeners, thank you for tuning in to another episode of The Future of CRE Sustainability. I'm your host, Sean. I'll see you next time.